Section 13, example 4. The diagram below shows the path of a rocket which is fired into the air. The height, h meters, of the rocket after t seconds is given by this formula. H equals minus 2t bracket t minus 14. Okay, part A says, for how many seconds is the rocket in flight? Well, we can see that the rocket takes off from this point and lands back in the ground at this point here. So really what the question's asking us to do there, how we would interpret the question is the rocket is in flight from this point to this point. So if we can calculate the routes here, and it's looking like the route here is definitely 0, if we can calculate this route over here, we should be able to answer this question, and it's pretty straightforward. So to find the routes, what you do is you make the equation equal to 0, because you can see that the height is 0 at these points. So where we see h, we're going to replace it with 0. So that'll be minus 2t bracket t minus 14 is equal to 0. And that means that minus 2t can be 0, and t minus 14 can be 0. Minus 2 times what gives you 0? That's 0. So t is equal to 0, or t is equal to 14. So my roots are 0 and 14. So for part A, for how many seconds is the rocket in flight? Definitely 14 seconds. Part B, what is the maximum height reached by the rocket? You can see by looking at the diagram, the maximum height of the rocket is here, at this point. Now, from a wee bit of symmetry and just having a think about it, you can see that that is going to occur at 7 seconds, and that's pretty clear from the parabola, from the curve. After 7 seconds, it's going to reach its maximum height. So to find its maximum height, all we would do now is where we see t in the formula, replace it with 7. So the height is going to be equal to minus 2 times 7 bracket 7 minus 14. Minus 2 times 7 is minus 14. 7 minus 14 is minus 7. Now, just be careful, a negative times a negative is a positive. 14 times 7, if need be, go across the side and work that one out. 7 fours are 28, 8 down, carry 2. That's 98. The units is meters. The maximum height reached by the rocket, and this occurs after 7 seconds, is 98 meters, and that's the end of the question. Section 13, example 5. A square of side x centimetres has a diagonal 6 centimetres long. Calculate the value of x, given your answer as a surd in its simplest form. There's kind of a variety of topics at hand here. There's a bit of Pythagoras, I would have thought, right angle triangles, a bit of quadratics, and simplification of a surd at the end. So first thing that I would interpret from this question is, if it's a square, each length is x centimetres. So the length of the square is x, the breadth would also be x. Now, by involving a wee bit of Pythagoras, and remember for Pythagoras, the square of the hypotenuse is equal to the sum of the square of the other two sides. So the square of the hypotenuse is equal to the sum of the square of the other two sides. It's pretty straightforward to see that I would get 2x squared is equal to 36. X squared is equal to 36 over 2. X squared would be equal to 18. And x will be equal to the square root of 18. Now, we wouldn't reach for the calculator at this point. Well, first of all, it's a non-calculator paper, but the question does say calculate and leave as a surd in its simplest form. So root 18 is a surd which can be simplified. Remember, for the simplification of surds, you think about your square numbers between 1 and 100. And taken out as a factor, I've taken out from the list the biggest one, which is a factor of 18. That number's 9. So square root of 18 can be written as the square root of 9 times 2. The square root of 9 is 3. So we can simplify it down to 3 root 2, and that's the final answer.